Every bottle cap has these tiny ridges around the edge. They're on water bottles, soda bottles, juice bottles, almost every bottle you open. But have you ever stopped and wondered why? Most people assume the answer is obvious. They think those ridges are only there to give your fingers a better grip. And yes, they do make bottles easier to open. But if that were the only reason, engineers could have used almost any texture. They could have made the cap rough, covered it with rubber, or added larger grooves. Instead, almost every manufacturer around the world ended up using nearly the same small ridges. That can't be a coincidence. To understand why, you have to forget about your hand for a moment, because these caps aren't designed for you first. They're designed for machines every day. Billions of bottles race through filling factories at incredible speeds. Some production lines can fill and seal more than 1,000 bottles every single minute. At that speed, there's no time for a machine to hesitate. Every cap has to be picked up, positioned perfectly, screwed on with exactly the right amount of force, and released all in a fraction of a second. Now imagine trying to do that with a perfectly smooth cap. The machine would struggle to grab it. It could slip while tightening. One bottle might end up too loose and leak. The next might be tightened so much that nobody could open it without a fight. When you're sealing billions of bottles, even a tiny mistake repeated millions of times becomes a massive problem. Those little ridges solve that problem in an incredibly simple way. Instead of squeezing a smooth surface, the sealing machine locks onto those ridges. They give it dozens of tiny contact points, allowing the cap to be gripped securely without slipping. That means the machine can spin the cap at high speed while applying almost exactly the same amount of torque to every single bottle. That word, torque, is the real secret here. If there's too little torque, the seal isn't tight enough. Air can leak in, carbonation can escape, and the product may spoil long before its expiration date. But too much torque creates a different problem. The cap becomes difficult to remove, the plastic threads experience unnecessary stress, and in some cases, the safety seal can even tear the wrong way when you first open the bottle. Manufacturers spend countless hours finding the perfect balance. Not the tightest cap, the right cap. And the ridges help make that possible. They don't just improve grip for the machine, they also improve grip for you. Your fingers naturally press into the spaces between the ridges, creating more friction than they would against a smooth, round surface. Even with wet hands, opening the bottle takes less effort because your grip is far less likely to slip. It's a small detail, but it's one you notice the moment it disappears. Imagine trying to twist open a completely smooth plastic cap. You'd probably squeeze harder, your hand would slide around the surface, and opening something as simple as a water bottle would suddenly become frustrating. Those tiny ridges are doing far more work than they get credit for. The engineering doesn't stop there. Those ridges also help manufacturers use less material without sacrificing performance. A completely smooth cap often needs a thicker outer wall to stay just as rigid during sealing. By adding a repeating pattern around the edge, engineers create a structure that's better at resisting deformation while still keeping the cap lightweight. That might not sound like a big deal until you remember the scale. Billions of bottle caps are produced every year. Saving even a fraction of a gram on a single cap can eliminate thousands of tons of plastic over time. A design that looks almost insignificant on your desk can have an enormous impact across the entire world. There's another reason almost every cap looks so familiar. Once a design proves reliable, manufacturers don't rush to reinvent it. Modern bottling lines are built to work with standardized cap dimensions, thread designs, and sealing equipment. Changing something as simple as the shape of the ridges could mean redesigning machinery, testing new production processes, and risking compatibility problems across entire factories. So the design stayed, not because nobody had a better idea, but because this one already solved the problem remarkably well. It's a pattern you'll find everywhere in engineering. The smartest designs usually aren't the ones that look the most impressive. They're the ones that quietly do their job so well that people stop noticing them altogether. So the next time you twist open a bottle, take one more look at the cap before you throw it away. Those tiny ridges aren't there by accident. They help robotic machines seal billions of bottles with incredible precision. They make every cap easier to grip, help apply the correct amount of torque, reduce manufacturing problems, and even save plastic when multiplied across global production. It's the kind of design most people never notice, because when engineering is done well, it becomes invisible. The best engineering doesn't always look futuristic. Sometimes it's hiding in something you've held thousands of times without giving it a second thought, and that's what makes it so fascinating. There are brilliant ideas like this all around you, hidden in everyday objects, quietly solving problems you never knew existed. All you have to do is look twice.